Part 283A, line 22f1fa18a, high temperature, tensile strength, TAS 8B, Waz-16, 713C, alloys, Wow Seti. Here's the alien radio signal. Here's a picture of the orange soil found on the moon back in the 70s or 60s, I should say. Apollo 17, yeah. I think it was 72. That's from, okay, so you want to see the video line 22f1fa, Saturn VAS 512, Eugene Cernan Moon Orange Soil Rocket Fuel 5G Wow Seti. It's a cross-reference with this video. Formula ideas from the data. TAS 8B nickel base alloy plus orange soil moon powder. See other formula ideas with this. 10th of July 2012. I'm going to Google tensile strengths as high as 2865 mn square, M at 480C. Appropriate treatments yielding materials with high temperature tensile and stress rupture strengths 980C, 1800 Fahrenheit were also devised. That's from www.researchgate.net. Strength enhancement process for prealloyed powder or superalloys. High temperature tensile properties of CUAG composites prepared by solution precipitation of electroform multi-layered alloys. DM Tench, J.T. White. Rockwell International Science Center Journal from 1992. Abstract. Appropriate heat treatments have been shown to convert CUAG multi-layered structures obtained by a new electrochemical periodic displacement process into homogeneous alloys or dispersed particle composites. The high temperature tensile properties of the latter are comparable to those obtained for similar materials prepared by conventional metallurgical techniques. Preliminary data also indicate that the as-deposited material may exhibit superplastic behavior under stress applied immediately at high temperature. And that's from ResearchGate.net. Fabrication of high temperature resistant oxide ceramic matrix composites from IHAL Dowry and E.G. Butler. Ceramic matrix composite group. Doesn't say what year, is from the UK. The main objectives of this work are to develop and apply new ceramic matrix materials by which a relatively high level of densification of the final composite may be achieved by pressureless sintering at temperatures close to 1200 degrees Celsius. A cost-effective processing method for the production of oxide CMC's materials and components has been achieved. A range of interphase materials is applied to Nextel 720 fibers. These include zirconia, neodymium, and lanthanum phosphate. A combination of ZR02 and the AKP50 alumina powder have been selected as the successful candidates for the interphase and the matrix material respectively. Work has been conducted on the preparation of slurry systems consisting of these two materials. The prime target was to establish the possibility of achieving good coating around the bulk of the fibers together with a high level of impregnation with the matrix material. Furthermore, the pressure infiltration technique has been applied, and as a result of composite samples with fiber volume content of 40% and remaining porosity of around 20% volume have been routinely produced. Composite room and high temperature tensile strengths of around 200 MPa have been accomplished, and that's from ResearchGate.net. Next is the Google TAS 8B nickel base alloy. Comparison thermal fatigue resistances of 26 nickel and ntrs.nasa.gov. So this is from 1975 from P.T. Bison. He's an evaluation of thermal fatigue resistance into google.ca. The application of directional solidification to a NASA nickel base is a book. Nickel base alloy, NASA Waz-16 with potential for gas turbine Stator Vane. Evaluation of two nickel base alloys, alloy 713C and NASA TAS 8A. So the application of directional solidification to a NASA nickel base alloy TAS 8B. So the keywords here, NASA Waz-16, Google NASA Waz-16, high-strength nickel-based alloy Waz-16 for application up to 2200 Fahrenheit. Author Waters W.J. Fresh J.C. Alloy product is high-strength, high-temperature nickel-based material with higher incipient melting temperature than all known nickel-based alloys. It is microstructurally stable and has high impact resistance both before and after prolonged thermal exposure. It contains relatively few alloying constituents and low content of expensive and rare metals. So it's from 1974. It's used for engine parts, furnaces, gas turbine engines, heat-resistant alloys, high-strength alloys, jet engines, nickel alloys, tungsten turbine instruments. It was updated 2010 from the ntrs.nasa.gov site. Next Google is alloy 713C from the nickelinstitute.org. Alloy 713C is a precipitation hardenable nickel chromium. The AMS 5391 specification for alloy 713C requires the following mechanical properties. Next one says alloy 713C337. Alloy has good castability, remarkable resistance to oxidation and thermal fatigue, and outstanding structural stability. And you're going to see the rest of the information come up in these videos here. There's a lot more videos. There's all the way up to FA19, 22. It just goes on and on. So these are the other videos with this alloys, about these alloys here. It's line 22f1fa18a high temps. Actually, I'll just let you look at it. But they're all connected together, so just so you know, those will be in the links and the tags on the videos too. Okay, we'll go to the next one.